Welcome, dear learners. Welcome once again. Today, again, I have come up with a new topic, that is mass spectrometry, and belongs to class 12 subject biotechnology under unit 5th, protein and gene manipulation, second chapter, protein structure and engineering. So, today, through this topic, at the end of this lesson, you will be able to know what is mass spectrometry and what are the components that makes this instrument, that is mass spectrometry, and how these components work together in the working of mass spectrometry, and what is the purpose of mass spectrometry. So one by one, the contents that we are going to discuss is what is mass spectrometry, the principle behind the mass spectrometry, what are the various components that make this instrument, and how these components work together in the mass spectrometry to give it a particular function. So first, what is mass spectrometry? In 1900, J.J. Thomson, for the first time, J.J. Thomson, he introduced this technique which employ fixed magnetic as well as electric field, and using this fixed electric and magnetic fields, the ions were separated on the base of mass and energy. So basically this technique is used to do the quantitative estimation of biomolecule, that is to measure the quantity of biomolecule. So which type of biomolecules? Like proteins, peptides or nucleic acids. So these biomolecules can be estimated, their weight can be estimated, quantity can be estimated through this mass spectrometry technique. So what is next is the principle. The principle behind this mass spectrometry is that the given biomolecule whose quantity has to be estimated, whose quantitative estimation has to be done, is first ionized and run under fixed electromagnetic field on the basis of mass by charge ratio. So by mass by charge ratio, they have been separated out. The molecular ions formed are separated out. So now let's talk about the instrumentation. In the instrumentation, or you can say the mass spectrometry has three major components: ionization source, analyzer and detector. So the biomolecule whose weight has to be estimated, or you can now call this biomolecule whose weight has to be estimated as analyte, okay, whose weight has to be determined. So this analyte is ionized first, and for this ionization sources are required. These ionization sources convert these biomolecules into gaseous ions, and when the biomolecules on once taken the charges, they either gain or lose a charge, that is through electron ejection or protonation or deprotonation. So molecular ions are finally generated. So in the ionization source, what happen? We make emphasis on creating the molecular ions of various charges. Now talking about the next instrument, that is the analyzer. So in analyzer, what happens? The ions, the molecular ions generated, as already told you, in the source of ignition or through the source of ionization, these molecular ions are separated according to their mass by charge ratio. Remember this, it is the important point, that by mass to charge or mass by charge ratio, these molecular ions are separated under the fixed electromagnetic field. So the analyzer provide fixed electromagnetic field to the molecular ions. Now finally, the instrument, the third component of this instrument, that is detector, it determines the mass spectra. It means that the molecular masses of separated ions, separated molecular ions, are determined from the mass spectra. So the molecular masses of the separated molecular ions is determined from this mass spectra, which is being created with the help of the detector. Let's take a quick recap of what the instrumentation is, of how these the components work together. So here we, through this inlet, we pass on our biomolecules whose quantitative estimation has to be done. Okay, when this biomolecules enters into this ionization source, then ionization source, with the help of energy, what it does, it converts these biomolecules, these analytes, into molecular ions. Okay, then these molecular ions, because they have different charges and differ in their momentum, they behave differently in an electric field, and they are separated, and these molecular ions thus separated on the basis of mass by charge ratio in this analyzer part. Okay, so deflection is actually taking place inside the analyzer, where the molecular ions, they are being separated or they are being run in the fixed electromagnetic field. Then these molecular ions, one by one, on the basis of their mass by charge ratio, are being detected by the detector as an electrical impulse. Since this impulse is very minute, so it is being amplified, and finally it is being recorded in the form of spectra on the chart recorder, and the peaks of these spectrums thus generate is helped to determine the mass of each and every molecular ions, which all together, when calculated, it gives the final mass of the biomolecule. So the working of mass spectrometry is dependent on the working of these three components separately. Once again, from the ionization source, the analyte molecule whose weight has to be determined is ionized, so that different mass of molecular ions are generated carrying different charges. Then in the analyzer, these molecular ions separate on the basis of mass by charge ratio, m/z ratio. And finally, these molecular ions are detected upon by the detector, and the impulse being very weak is amplified by the amplifier, and these impulses are recorded on the chart on the in the form of spectra. So this is how the mass spectrometry works. So important points to be taken care of is that the principle of working of mass spectrometry is to create the gaseous phase ions from the polar charged biomolecules like peptides, proteins and nucleic acids. Also, the molecular weight of the biomolecule whose detection is being done, whose weight is being determined, is must be more than 1299 daltons. So it could give a better result in multiple charge ion. Also, there are many suitable sites of protein which undergo protonation. There are all the backbones of amide nitrogen atoms and side chain of amino groups which can be protonated. Also, its important fact about this mass spectrometry is that it is an essential tool for analysis of genome and proteome. And it is capable of identifying, characterizing proteins present even in picomoles, that is 10 to power minus 12.